Hello, this is Mrs. Pi. This will be how to go from rational form to radical form, and radical form to rational form in powers. This is the basic rule. And using some numbers, it's like that. So the numerator goes inside. So hence we have x to the 5/3. It goes x to the 5th inside. The 3 becomes your index, which is outside. Number inside we call the radicand. And the numerator becomes the power on the radicand. And the denominator becomes the index of the radical. So this is how we go from a radical to a rational exponent or a fractional exponent. Let's do a few more examples, and then let's throw some numbers in front. Okay, so we have x to the 6/5 power. That's the 5th root of x to the 6th. Or if you have x to the 2/3 power, that's the 3rd root of x squared. You also could write it as the 5th root of x all raised to the 6th power, or the 3rd root of x all raised to the 2nd power. It's your choice. What happens if it's negative? Well, if it's negative, it just becomes a fraction. We'll do one example. So you have x to the negative 1/8 and x to the negative 3/5. So this will be 1 over the 8th root of x. This will be 1 over the 5th root of x to the 3rd power. Remember, the basic rule is x to the negative n is 1 over x to the n. And we're doing x to the n over d equals the dth root of x to the n. I'm using n and d because the numerator over denominator. Numerator goes on the radicand. The denominator becomes your index. Okay, let's go backwards. So if we started with the 4th root of x to the 7th, that'll be x to the 7 over 4. Another example, 3 x to the 8th, x to the 8 over 3. 3 things to remember. 1, you could simplify these. Let's say you had x to the 10th, the 5th root of x to the 10th. That'll be x to the 10 over 5, or x squared. Another example, if you had the 6th root of x to the 4th, that's x to the 4 over 6, or x to the 2/3. Okay. 2 more examples, and then we'll wrap up. One thing to point out before we do the last 2 examples is that if you had a half power, say 11 over 2, and you follow our rule, you have this 2 on the outside, x to 11. Since it's a square root, you don't have to actually write the 2 there. These two are the same thing. This is the 2, x11, when the index is 2, you don't need to write it. This and this are the exact same thing. Okay? Let's say a number's involved. Let's do a few examples with numbers. let's first do something to review with negative exponents so you get the basic idea what I mean. So you have 5x to the negative 4. That's 5 over x to the 4th. These are interchangeable. Same thing here. 2/3 x to the negative 2 is the same thing as 2 over 3x squared. Remember, a negative exponent just becomes a denominator. And you can think of it the same way when you come to fractions and radicals. What I mean by that, if you had 7 square root of x, same thing as 7x to the half. You had 3/5 root of x, that's 3 times x to the 1/5. There's a reason why I prefer this notation, because it's easier to tell that that 5 is not 35, but it's part of the radical. 2 more examples, just to get the point across. So if we had 13 cubed root of x squared, that would be 13x to the 2/3. And let's really make it interesting. 5 over the 11th root of x to the 3rd. That'll be 5 times x to the negative 3 over 11. That's how you transfer these from power form to radical form. Do 2 examples in the last slide just to wrap it up. And let's do that. So let's go over the basic idea. This video was on how to transfer power form to radical form, how to transfer radical form to power form. And the basic idea is you add 3 over x to the 3rd power. That'd be 3 times x to the negative 3rd. And if you had 7 times the 5th root of x to the 4th power, that'd be 7 times x to the 4/5 power. And the basic 2 rules are a negative exponent becomes 1 over x to the n. And if you have x to a fraction like n over d, it becomes a dth root of x to the n. And remember, x in all these cases cannot equal to 0. Well, in some of the cases it can, but let's avoid 0 in general when it comes to fractions and negative numbers. Okay, this is Mr. Spy signing up. I hope this video was helpful for last week, Thursday, February 5th lesson in my class, and for any other YouTube people watching this video. Subscribe to this channel, put the bell on for notifications, and there'll be more videos going into more depth working with fractional exponents coming up. Have a great day.